All right, we're getting started. We're a little bit earlier than usual today. So welcome back to another installment of PyData. For those of you who are new, welcome to your first one, and everybody else, welcome back. As always, we'd like to acknowledge some of our sponsors. So we'd like to thank NumFocus for sponsoring this event, this meetup, TD Ameritrade for sponsoring the space and the venue, and also to Midas University at the University of Michigan for sponsoring the food. Technically, today is our 1-year anniversary, so you might have noticed the cake sitting out front. Yay! We're pretty excited. Key points, for those of you who are new, emergency exits. There's one right out over here, and then to the right of the door that you entered through. As always, we're soliciting for speakers, so if you'd like to give a talk. Next month is an opportunity, we'll get to that. As always, we're looking for feedback too, things that we're doing right, things that we're doing wrong. Please feel free to let us know. You can always follow everything that we're doing or find speaker decks on our GitHub page. And especially for the respect of our speaker, please hold your questions until the end unless they're quick. And we'll probably try to keep the time for questions a little bit shorter today because our speaker needs to catch a flight at about 8:25. So let's hope that the weather is going to hold up for us here. And also remember that you're in a borrowed space, so please do clean up after yourself. And we will be doing cake afterwards. I'd like to always read our PyData Code of Conduct. So PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate for any of our meetup events. Be kind to others, do not insult or put down other attendees, behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers, but basically don't be a jerk, right? is what we try to go for. But thank you for making this an inviting environment for everybody. A quick little icebreaker. So that you meet somebody, hopefully, either turn to somebody on your left or your right, introduce yourself, and say if you owned a pet growing up. And if not, maybe why. Right, real quick.
Second one. I noticed you are Canadian. Mine is one of the branches right now.
All right, we're back. Thank you. So just to point out, it is the month of madness. So this month in data science, Kaggle is running a competition to try to predict the NCAA, both men's and women's brackets. So you might want to get on there. There's a $50,000 prize money. Also, TD Ameritrade, there's a team, Logan Alstrom over there, his team is hiring a data scientist, data analyst, and a Java/mobile developer, as well as there's an announcement from Ben over here from DataSpace.
Thank you. I'm Ben from DataSpace. I'm kind of a recruiter with a soul. I just want to let you know, if anybody's interested or knows anybody who's interested, I'm looking for SaaS developers in Lansing, data science guys here in Ann Arbor, SQL Server developers in Dearborn and Orange County, California. I need a ClickView developer in New York City and an SSIS and Power BI developer in Dearborn. So if anybody is looking for something new or knows someone who is, please send them my way. Once again, my name is Ben. Thanks a lot.
And do you want to hold up your hand too, Logan, so that people recognize your...
If anyone's interested, jump talk to me afterwards.
Excellent. And of course, plugging in the next event, we're going to do our lightning talks again. So last October, we had our first round of lightning talks where people in the community here could come out and give a talk. We're probably going to tighten it up and do 7-minute talks. And we're going to have the first 6 people who sign up be giving a talk. So look out for the registration for that, both to give a talk and to attend. And that is going to be taking place on Tuesday, April 10th. And then without further ado, I'd like to introduce our speaker today. We have Holden Karau, who is both prolific in the data science space, as well as, similar to many of our speakers here, an author of the books on Spark, O'Reilly books on Spark. So let's give her a round of applause.
Thank you. And I just put a Linux laptop into suspend, so let's all hope that it comes out. Yay! Okay. Oh, fuck. Okay, cool. Yeah. Well, that worked. Let's call it working. Yeah, or FNF. Cool. So this is a fast introduction to Spark, now with vectorized UDFs. Yay! Vectorized UDFs are exciting. If you would like your code to go fast, or you just want an excuse to rewrite everything, it's pretty great. I'm gonna move this microphone so it picks up a little less of my movement. And yeah, cool. So my name is Holden. Preferred pronouns are she or her. It's tattooed on my wrist, in case anyone forgets. It's very handy in the mornings. And I am on the Spark PMC. You can think of it as being like a committer, except it's kind of like a shitty version of tenure. I can't get fired, but I don't get paid. So that's... or I could get fired, but it would be a lot of work. Previously, I worked at a bunch of different companies. Most of it's big data. A lot of it was search and recommendation problems. And I'm a co-author of these 2 O'Reilly books. There's one of them here today, actually, High Performance Spark. And you can follow me on Twitter if you want. In addition to who I am professionally, I am trans, queer, Canadian, and part of the leather community. And this is just a reminder that we all come from different backgrounds, and as the introduction said, we should be nice to each other, regardless of where we come from. And I'm actually here on a work visa, and I really hope y'all keep those, because I like this country. Anyways, without further ado, I'm hoping you're nice people. I am actually really curious. How many people use Spark? That is some. How many people are like vaguely interested in Spark? Cool. How many people don't really care about Spark? Like, that's totally legit. Okay, 1. Cool. No, it's cool. We will look at some interesting distributed system stuff in general, and you don't have to use Spark. It's quite all right. My employer makes money by selling compute time. They don't really care what you run. So we're going to talk about what Spark is. Yeah, we're going to skip getting Spark set up locally. That's not going to happen before my flight. And we're going to look at Spark's primary distributed collections. We'll do everyone's favorite word count example. And then we'll rewrite our word count example using the vectorized UDFs. And this will show us that the vectorized UDFs are really fast, but also we didn't do a great job on that design part of the API, because it's actually surprisingly difficult to do word count with them. And that was kind of, oops. Anyways, we'll fix it later, I'm sure. Probably, yeah. So, right. I think Spark's pretty awesome, but obviously my success is tied to the success of Spark. So there are other systems which are pretty awesome too, which I make less money on. And so you should totally take everything I say about how awesome Spark is with a grain of salt. And yeah. I'm also super jaded. So when I say that Spark is terrible, you should take that with a grain of salt too, because that is going to happen. So yeah, Spark is a general purpose data parallel system. It's an Apache project. This is nice because it means that different vendors who hate each other can work together. and it's faster than Hadoop MapReduce, and I really want to give a shout out to the Hadoop MapReduce community for setting such a low bar. Thank you. No, Hadoop MapReduce is a wonderful tool. It's great at what it does, but performance-wise, they left a lot of opportunities for improvement. And it's good for when our data gets too big for a single machine. Right. So Spark is not just this core distributed execution engine. It is a whole bunch of crap. There are two separate graph APIs. Conveniently, neither of them work. They compile in Scala, and I don't actually think we expose them properly in Python ever. We have an old machine learning library and a new machine learning library inside of the same project. That's not at all confusing about which one to use. And that went over so well with the community that we decided to make two separate streaming APIs as well. Realistically, we just didn't want to break the old APIs. We wanted to keep people's code working, but we wanted to take some of the things that people yell at us in the street when they find out we're Spark developers and be like, okay, I'm going to fix that bug, sort of. But we would have broken a lot of people's code if we tried to just, retrofit it on the old legacy APIs. So why do people come to Spark? MapReduce jobs as a good reason. It's taking, 16 hours or maybe 72 hours, and you're like, I bet I could learn Spark before my MapReduce job finishes. This is sometimes true. The other one is my data frame does not fit in memory on my cluster anymore. Other people are like, it definitely doesn't fit in memory on my MacBook Pro. This is when I need distributed computing. And I will encourage you to perhaps wait a little longer. You can buy bigger machines than a MacBook Pro. But, if you want to use distributed computing at that point, I make money, so that's fine. I won't discourage you that much. Now, if anyone's really excited about this, and is like, I really love following along with examples that are on slides in notebook environments. I have a notebook with the examples from today in a little bit more of a sort of structured manner to lead you down using the ML APIs. We're going to do a little more of the intro stuff today. But if you want to follow up, this is the place to go. And you can play with those notebooks and tell me what's broken in the newest version of Spark, because I haven't had a chance to update it because that came out last week. Okay, so the first thing that you get when you start up Spark is you get a Spark context. And we can think of this as our entry into the world. We can use this to create distributed collections. We can do this from all sorts of different input sources, from HDFS to things that look like HDFS, to S3. We can even take local files and turn them into distributed collections. This works pretty well. We can create counters and accumulators, which sound really useful but don't actually work the way anyone wants them to. So don't use those. And yeah, we can connect it to all sorts of different backends. We can connect it to a local backend, which will just run a sort of a simulation of a cluster on our laptop. We can connect it to a Spark cluster, or we can put it on top of Yarn, your existing Hadoop infrastructure. As of about a week ago, you can also put it on top of Kubernetes, but that shit just... I love the Kubernetes people and I love the Kubernetes on Spark people, but it feels like a V1 API. We're working on it. I do not encourage you to run Spark on Kubernetes in production. That's just going to go real bad. Right. So what is an RDD? It's resilient and distributed. And the resilient part is super important, right? If I'm working on a single computer, right, I can sort of say, if this computer fails, my program is going to fail, and that's just kind of life, right? But when I have 100 computers, if I say, if one of these computers fails, my job fails, then that starts to approach like my job is never going to succeed, especially if I run on top of, some commodity hardware. And Spark takes a really different approach to achieving this resiliency. It uses recomputation on failure. So essentially, it keeps track of all of the things you've asked it to do. And if one of the computers with information it needs goes away, it goes back and just computes the missing piece of data. The classic MapReduce model instead writes out the results to 3 different machines. And that works as well as writing to 3 different machines over a network file system works, which is to say it succeeds, but it's slow. And one of the weird parts about RDDs is that they're lazily evaluated. And this is actually it's really super core to how Spark works. And this is what we use to build this resilience. By not executing the actions immediately, as I call different things on my distributed collection, I just build up a graph of operations. And I only execute this graph when I'm finally forced to, much like a teenager taking out the garbage, right? You ask them to take out the garbage. They say, yep, done that. And then you go and you check and the garbage is still there, and then the teenager eventually takes out the garbage. In theory, I don't know. That never worked on me. Okay, so everyone loves word count, right? We're pumped for word count. Come on. Yeah, I'm getting some fist pumping in the back. Admittedly, pretty sure it's insincere. It's okay. So what does this look like? So our SRC could point to a distributed file system like UDFs. It could also just be a local file on my computer. I have this very fancy space tokenizer. Works super well for English. And because I live in North America, I get to pretend that's good enough. And then I go ahead and, so this first call gives us back an RDD, right? And it's important to note that even if our input file didn't exist here, Spark wouldn't complain. Spark would be like, cool, I got you. It's only when we actually go and call save that Spark will be like, oh yeah, when I said I got you, what I really meant is, your file doesn't exist, so no. And so that's just really lovely when you're debugging. And so, okay, the other thing is, this is also an RDD. So this words thing here is created by taking our input data and applying a transformation where we take each input and we split it on spaces, and this comes into a list. And then flat map means that it gets flattened. And so this is just an RDD of all of the words from our input, and then word count, et cetera, et cetera. And the nice thing is, yeah, these don't exist, right? They're just nodes on a graph, and some of these nodes will actually get collapsed down together, right? It will probably actually say, well, if I'm gonna tokenize these, I can make that word and the number 1 go together at the same time. I don't need to do 2 separate passes over my data. And this is also really nice, and I'm sorry for all of the MapReduce jokes, but this is really nice because in other classical systems, you spend a lot of time thinking about how to chain all of your things together into the minimum number of passes over your data, but Spark does this for us. I mean, at the slight cost of not understanding what's happening with our software, but it's not like debugging is a core part of our everyday activity. All right, so this is cool because we get pipelining. That's laziness. This we call the graph a directed acyclic graph because they wanted papers. We use acronyms for lots of papers. And we can do all sorts of interesting optimizations here. There is this other catch. To actually make this DAG work, right, if I'm going to recompute my data on failure, I can't have my data change on me, right? So if we go back here, right, and the first time we went through this, words was one thing, but then later on I modified words, but something in word count failed, I would be in a really weird state and I wouldn't really know what's happening. So all of these collections are immutable. And this is important, and yeah, whatever. Cool, yay! Here we go, we have it color-coded. Color coding was more exciting in my head. Okay, right, so there's a catch though, right? This magic is really cool, right? Spark has done some cool magical optimizations for me inside of here. But one of the things which it hasn't done is, let's say that I wanted to do something instead of just counting the words in my input, right? Maybe I'm actually loading some log data and I care about finding all of my error messages and all of my warning messages. The problem is Spark is not a compiler. It cannot see into the future either. It doesn't have a DeLorean. And so when it gets to this action stage, right, it has no idea what's going to come next. So all it can do is look at the graph we've created so far, and it has no idea for any future graphs. And so you really have to help Spark out because this is how our programming model works. If you want to reuse any of your data, and you have to tell Spark that this data should be kept around rather than being thrown away to make room for new data.
Just to see if I understand it correctly, lines, say the first line, is not actually evaluated to lines.
Yeah.
So a debugger will not. If I try to say print it to console, it will not be lines.
Right, yeah. So if you tried to print this to console, so if you tried to print lines to console, what you would see is like the repr would just be RDD, right? And that would contain no information for you. It's great. Yeah? Okay. Whatever. It goes a lot faster than the alternative. And that's sort of the bargain that we made with Spark, which was like, I'm not going to understand how anything's going to work, but you promise me you'll run pretty fast most of the time. And they were like, yeah, sure. Want to fund my startup? Anyways, yeah. Cool. Right. Magic. Yeah, magic. Okay. So in addition to map and flat map, there are a lot of different things that we can do on top of an RDD. And these are things which will give us back new RDDs. And they are lazy like a panda. And so map and filter and flat map. And some of these things probably seem really similar from the itertools collection. And that's because they are. They're just functional programming concepts that happen to be implemented on a distributed collection. The join is a little different because this operates on multiple RDDs. So you can join two separate pieces of distributed data. And reduce by key is also a little bit different because the first three can just be done processing locally on each machine, but a reduce by key, we might not actually have all of the same information about all of the information about each key on the right machine, so we have to shuffle it around. And the actions are the thing which make Spark do the work. And so if you were debugging this, actually a really common pattern is to use the count action, which is kind of useless. It just tells you the number of elements, but it forces Spark to do the work. So if you thought that your input file might not exist, you could call count on it right after you'd loaded it, and then Spark would actually check and see what was going on. And yeah, lots of other things. Okay, and this can feel like magic. I mean, not like especially good magic, but magic. But just like anything that's magical, right? If people remember like early Ruby on Rails and how happy it was, the magic has its limitations. So we can do something that looks pretty safe, and instead it'll actually make our cluster fall over. And so we can do a bad version of word count. And part of this is there's this thing called group by key, which I really regret that we ever implemented it because it sounds safe to people who come from really any background besides distributed systems. And even if you come from distributed systems, it sounds pretty safe. And what happens is this will make a group, and we are used to Spark making this graph and optimizing this graph, but there's sort of a limitation to this graph. This graph can't look inside of our lambda expressions, right? Here we're computing a sum, but Spark's graph only really knows that we have some Python code in here. So it can't take the sum and pipeline it up. It actually creates a giant list and then has to do this computation. And this giant list could be too big to fit in memory. And so that's unfortunate. It's not magical, but we learned from some of our mistakes with this API. We were like, lambdas are awesome, but maybe not everything has to be done with a lambda expression. We can do other things, and then Spark can see inside of more things. We can give Spark X-ray vision. Oh, right, this was a Ford Pinto catching on fire. It turns out difficult to find a Ford Pinto on fire photo. Surprisingly, that's Creative Commons license, so I applied my Photoshop skills. Don't actually have Photoshop. I run Linux. But, you know, Google Slides, same thing. Okay, so this is a wonderful segue into something that claims to solve the problems that I just showed you, which is Spark's Dataset API. Also known as Spark's Data Frame API, And if you come from pandas, that sounds exciting. But do not worry, dataset is a much more accurate name because it don't look like a data frame. We get a really smart optimizer, we get better serializers, and we get window operations. The window operations and multi-column, multi-typed aggregates are things which are really simple to do on single machines, but really annoying to do on distributed systems. Like eminently doable, it just involves writing a lot of really fiddly code where I reverse two things, and then we get the average wrong, and I have to update my resume. And that's awkward, right? You never want to be like, yeah, this lambda expression is why I'm looking for a job in your next interview. I joke. People don't normally fire me for that. So there's a bunch of things. The strongly typed part doesn't actually work in Python for pretty obvious reasons. But all of the other stuff is pretty cool. We get nice performance of Spark SQL. We can actually write inline SQL. Does anyone like writing SQL? That is, oh, don't be ashamed. No, own your SQL. Own it. Girl, there is nothing wrong with SQL. In fact, SQL has a lot of really nice properties when it comes to distributed systems. It is really hard to figure out a lambda expression. It is way easier to figure out a SQL expression, right? And so if I'm trying to build an optimizer, I want to build an optimizer for something I can understand, because otherwise I start looking at Python bytecode, and trust me, I've done that. It took me 6 weeks. Not really. Okay, it took me 2 weeks to switch it from Python 2 to Python 3, but those were not 2 weeks of fun. Those were 2 weeks of like really bitter despair. And then I gave up, said like whatever, some bad words, and deleted some functionality, and it worked. Anyways, cool. So I have this vendor benchmark. Now, admittedly, I'm not like selling you software. I don't make money that way. But you should definitely take what I say with a grain of salt, as I am a vendor. That says, if you use this new thing, it totally runs faster than the old thing. And this is true for computing some random metrics that showed me this. Don't worry. I tried a few things until I got the answers I wanted, and that's where the slide came from. But like, it actually really often is an improvement. I'm just saying, don't just do it and assume it'll get better. Measure it, and then double check. So how is it so fast? In addition to carefully selected benchmarks, the optimizer gets some additional information when we start writing in the data frame or dataset API. And the other part is, and I'm sorry about this one, we actually do a bunch of your computation in the JVM behind your back. And I'm sorry, but it's okay, because that kind of goes faster when it works. When it doesn't work, I'm really sorry. But this can make it go a fair amount faster. So let's look at word count again. Yay! Damn it. Okay. So we have a very similar loading of input data. We have spark.read.load. Why we made it longer, I don't know. But this gives us back a data frame rather than an RDD. And then you can see this starts to look a little bit like SQL. We have a select expression. Ooh. We still have our flat map with our lambda expression. Now, the thing is, we're not going to get a lot of speed up because of the flat map here with the lambda expression. It can't magically start looking inside of our flat maps, but it can look inside of our group by and our sum, and it can actually understand our group by is just on this column, and then I'm just applying the sum to that, and I can have group by and sum, and my code probably won't fall over if the optimizer did its job right, which is about as reassuring as anything gets in distributed systems. And so this is nice, but this part is still kind of slow, right? So we're gonna try and make it go faster. We're gonna do more word count soon. I promise. I know everyone's on the edge of their seats. But what is the optimizer able to do? So one of the things that makes PySpark kind of slow is that we use this serialization called pickling. Everyone loves pickling, right? Super fast, very space efficient, and definitely easy to be understood in the JVM. all you have to do is manually smash some bits together, and you can probably figure out if it's an integer. And yeah, that's pretty much where we're at, right? So because we have to work together between Python and the JVM in Spark, using the pickle serializer gave us a lot of flexibility for pretty much handling any type of data Python wanted to throw at us, but didn't give us a lot of information about the data we were working on. So we use a different serializer now, and it's one where we actually understand the data in both. And don't worry, we have a new serializer that will fix even more problems coming soon. It's in Spark 2.3. And yeah, it gives it a lot more compact representation. So group by returns a group data, a frame, or a group data set if you're working in Scala, and it has a bunch of built-in aggregates. And if none of the built-in aggregates are the ones that you want, you can still write your custom aggregation with a bunch of Lambda expressions, but it'll keep you from just calling sum, right? It'll keep you from doing that thing, which looks really safe, but is actually super dangerous. And there's built-in shortcuts if you want to go look at the long list. It's over there. Right, okay. Now, oh, oops, this one's Scala code. Pretend that's not here. Pretend this import statement isn't here. I'm sorry, I have to talk to JVM people too. It's okay. Actually, yeah, just get rid of the import statement, spell it in Python. And so we can group by age, compute the minimum number of hours per week, or we could compute multiple summary statistics at the same time. Yay! I didn't have to write a reduce by key with 3 separate tracking variables. This is so exciting. It is so incredibly basic, but working with Spark for long enough will make you so excited for simple things, where you're like, yes, I can compute the average of 2 numbers. And then like people taking like computer science classes are just like, what now? I'm like, no, it's really cool. And then normally that's when I'm alone in the coffee shop. But that's also why I travel with my stuffed animal. Anyways, moving on to other things. So I promised you that this thing is going to save you, right? And I'm probably trying to convince you to rewrite a bunch of code you already have, right? Especially since there were a bunch of people who already seem to work with Spark. It would be a disservice if I did not tell you where I know data frames are bad. And one of them is iterative algorithms. So if you're going to try and build a machine learning algorithm or a graph algorithm on top of data frames, they're going to behave really poorly, which is why we built our new machine learning and graph algorithms on top of data frames. Yeah, that's not a joke. Or it is, but like a really intense one with a lot of software behind it. Thankfully, there is a little escape hatch where we can just go, oh, yo, it's been great knowing you data frames, but I'm just going to go back to RDDs. It's like, don't worry, I'll be back. But essentially, if you're going to do machine learning, you're going to end up using RDDs under the hood of it. Has anyone had to tune a Spark job in production? No one. You are all very lucky people. Essentially, the other thing that you'll get with Spark SQL and data frames and data sets and whatever else we decide to call it is a whole bunch more knobs to tune. And yeah, so the guide list of knobs for Spark doesn't fit on like 4 pages, and the SQL ones are a separate collection. So start buying your ops team brownies, cookies, whatever it is they like to butter them up for the future of deploying this into production. Okay, I promised that I was going to show you machine learning. And so Spark's machine learning API, the new one that we built on top of data frames, which is bad for machine learning, is very scikit-learn inspired. Pretty much looked at the scikit-learn APIs and said, ooh, that was a much better idea. Let's just do that. But then we decided to make some other poor decisions. And so our stages are broken down to either estimators or transformers. Estimators have to see data to be fit, and once they're fit, they produce transformers. Transformers can be the result of fitting an estimator, like I can fit an naive Bayes model and this will give me a naive, I can fit a naive Bayes estimator, which will give me a naive Bayes model. Or they can just be like purely stateless things like hashing TF, or our good friend, the space tokenizer. Now, data prep looks, well, honestly, if your data prep looks like this, you're probably doing something like a Kaggle competition or training on mnist.csv, which is legit. The important thing to note is this is like the simplest data prep that you can do, but we can essentially see that we can create different stages and we can put them together into a pipeline. Most likely you're going to have to do a lot of data cleaning. There are a bunch of tools in Spark to do data cleaning. That is unfortunately a topic unto itself. And it's not complete without an actual decision tree. So we're going to go ahead and make our little decision tree classifier. And then we say that our pipeline does these three things. And then I go ahead and I call pipeline.fit, fits all of my components, and gives me back a model. And that's great. The only problem is sometimes fitting these things could take maybe days. If you're on mnist.csv, probably not days. But, you know, this can take a really long time. And I don't know if you noticed, we've got this label column as a string and this feature column as a string. This isn't being picked up. I'm typing this in manually. And so the odds that I eventually mistype my label column one day and my final step will be training my decision tree classifier after doing all sorts of other work is pretty high. I don't know what the odds are for you. Maybe you pay more attention to your jobs. But a good trick is to run this on smaller data rather than big data first. Just sample your data, run it through, make sure this pipeline works, then run it on the big one. Otherwise, you will eventually come in the next day to find out that you wasted an entire evening. Admittedly, if your salary, whatever. I don't know. Okay, so I've alluded to this a little bit. That Spark is in the JVM for the most part. And so how do we actually make this work? How do we actually make Python and Spark talk together? So we use Py4j, pickling, JSON, and we actually now use something else called Apache Arrow, and a healthy dose of magic to glue all of these together. These can be kind of slow. Arrow is faster than the other ones, but yeah. If anyone, are there any R users in the house? Please don't feel ashamed. Okay, lovely. Well, no, after the SQL thing, I just want, you know, it's all right that you use different technologies besides Python. The right tool for the right job, right? Or whichever tool pays me the most. And so Spark R uses the same magic. So the stuff you'll learn here is pretty much what everyone else does too. And so this architecture diagram, in addition to illustrating that I don't work with a graphic designer, can show you that on our sort of driver program, which is like our laptop or the jump node to our cluster or where our Jupyter kernel's running, we have a Python process talking to the JVM over sockets. Yay. This is kind of slow. Py4j is a little slow. But it turns out it doesn't matter that much because normally all we're doing is telling the JVM what we want done. We're not transferring a lot of data here. All of the data transfer happens here, which is where we use Unix pipes.
Slow.
Yes! And as mentioned in the front row of the audience, that is slower. Yay! Also, oops. So, not the best design decision, but working on it. We use sockets in some cases too. But our data is essentially copied from the JVM into Python and back. And so naturally, that is not fast. But we're working on it. And we actually made substantial improvements a week ago that are actually available to be deployed into production if you're looking for a new job. And so that's the present, faster interchange. So it's technically released. It's in Spark 2.3. It is the first release with this in it. So it will probably have a lot of bugs. Notably, I'm pretty sure it doesn't handle date-time data correctly. So please don't put dates through it unless you really like UTC. If everything's in UTC, I am so jealous, and it might work. The other nice thing is that arrow, in addition to being understood by both Python and Java, is also understood by the fancy people who make the CUDA language. And so if you've got some GPU acceleration going on for your deep learning, we got you. I don't know. Probably, you've got a bunch of self-driving cars out here, right? You probably have to do deep learning on GPUs, whatever. In the Bay Area, normally you do deep learning on GPUs because you're trying to raise more money, not because you don't want to kill people. That's sort of optional. Okay, yeah. So it is possible that it is in Spark 2.3. It's an open source project. I can't guarantee you that it is the future forever, but things look really promising. The early benchmarks from the vendors who try and sell you things are quite promising. This is a benchmark from one of my former employers, and you can see it could run 200 times faster. That is bullshit. More politely, that is a carefully selected benchmark, and I applaud their choice. And it is true. It could run 200 times faster. It is unlikely to, but I think you will see real performance speedups in the 2x, 3x range. Admittedly, I am also a vendor, so please double check my gut feelings with your own actual real code. Okay, so what about if we wanted to actually write some UDFs? So we all know that Python is great for numerical computation. So I decided the best demo UDF was adding the number 1. It's legit. You don't want to trust the JVM to add 2 integers together. I don't know what I'm getting back. So here I can write this pandas UDF. I tell it that it's an integer, and I tell it it's a scalar, and that I add x and the number 1. Yay! This will run a lot faster, mostly because all of your work before was simply copying the data around. You weren't spending any time really adding this number 1. So this might get 3x faster. But you might also actually want to do things with group data, right? This is very much not group data, right? I don't have it sorted in any way. But you might have switched to the fancy, group by key on data frames, in which case we use this grouped map structure, and then this PDF, our pandas data frame, is going to represent an individual group, and we can go ahead and do our operations on this. And that's really awesome too. It goes faster, I promise. This is the one which goes 200 times faster. I really don't know how they got that number, but it's okay. But it seems like people aren't super buying this, so we're going to go back to word count. Word count. It's like I knew everyone loved word count. Okay. My original plan was to use spacey, but then it didn't fit on a slide. But the important part is we could actually put something interesting inside of here. The only really sad part is that this is really not very elegant code, right? If you think about our previous word count example, you could print that on a t-shirt and maybe be like, yo, what's up? This is cool. Or at least you could in San Francisco, because we got really low standards for fashion. But if you put this on a t-shirt, people will be like, okay, so if the string is not none, I make a new data frame, and wait, what? And so it turns out we did a bad job. In our scalar example, we required that the inputs and the outputs be of the same size. So when we want to tokenize things, for each input, we might want to produce 0 or more outputs. And so we can't use this, which is really the API we should be using. Or, it's the API which looks nice. Instead, we can use this weird group thing, because we don't have that restriction in the group data. And please don't actually do this word count. This word count will run slower than the other word count. My attempt to make it go faster actually made it slower. That's life. Because we actually have to do a group by so that we can have some group data. And it turns out doing a group by causes a shuffle. And that's just instead of saving myself. So I've reduced the amount of time it takes to copy the data from the JVM to Python for the cost of copying my data to different JVMs across a network. And it turns out that's much slower. The network is slower than even pickling. So this was a bad idea, and we got to revisit this so that this word count can also be a happy word count. And then we'll have 3 happy word counts. Anyways, okay. So before I leave you with Spark, I want to point out that everything else is terrible too. And in different ways, but a lot of other systems looked at Spark's design decisions and for some reason were not horrified and said, you know what, I will do that too. And I'm just like, oh, no. Some of them looked at it and said, I think it's missing XML. And for those people, I say, perhaps not. But it's okay. When your alternative is pickled objects being parsed in the JVM, I understand desperation. And there's another option too. Anyways, okay, yeah. One option which actually did not look at Spark, or well, it did look at Spark, and it looked at Spark and went, oh no. That was a bad idea. We are not doing that. It looked at some of Spark and went like, ooh, I like distributed computation, but I don't like the JVM. The JVM is not my friend. And it's actually, it gives you a data frame interface which looks a lot more like a pandas data frame. It's written in pure Python, which means that we don't have this memory copy challenge. Well, I mean, pure Python, so there's a bunch of C code, and probably a little bit of Fortran, just to keep things going. Its big problem, though, is because it's pure Python, how many people actually work in 100% Python shops? Okay, yeah, so that was not a lot of people. And that's sort of the challenge, especially in big data shops. We tend to be working with other people who produce data in formats that really aren't suited to being parsed by Python directly right now. Our options for parsing Parquet data, not so good. And that's sort of where Dask is. There's also Ray, which is a similar project from my research lab. I don't know which one's better. Neither of them pay me, so I don't really care. Beam is produced by a large number of people, including my employer, so they, of course, deserve a slide. It essentially looked at Google's design, it essentially looked at Spark's design and said, you know what, I'm just going to use a bunch of internal Google technology. I mean open source, but I'm going to use a bunch of Google technology instead of pickling, and that'll probably go better. And it turns out, kinda. But not the greatest, because we fucked up some other parts of our design. But if you want to come help us fix them for free, it's an open source project, and you can totally do that. More seriously, I think like if you're interested in working in a Python open source project, it's kind of neat. And it also doesn't support Python 3. I meant to fix that over the holidays. That did not happen. Especially because people keep writing more Python 2 code. It is really hard to get rid of once it's in your project. Okay. And I want to close out with the final option, is there's a really good chance that you don't need any of this stuff. You might just be fine with multiprocessing. And actually, this is kind of nice. Dask notably supports multiprocessing as a backend. You don't have to run it on a cluster. You can tell Dask to run it in sort of multiprocess mode. Spark also, to some degree, has a local mode. Dask's local mode is a lot more lightweight, and there's less overhead involved, because you really don't need the JVM involved when you're just running on one machine, right? JVM really is bringing nothing to the table at that point. But on the other hand, you know, when it comes time to scale, a little more hands up. Okay, right. More important, I have a new book. You can buy several copies of it. Don't waste your money on it if you're a student. But if you work for a corporation and you have an expense account, it is an excellent gift for people that do not know how to return things to Amazon. Also, I recommend having your cat sit in the box, because then the cat will pee on the book, and you probably can't sell it on the second-hand market, and this will keep the prices high. Anyways, and cats do love the box that the book comes in. I have at least one testimonial. I will be talking at a bunch of other places. If you want an excuse to come visit London, I'll be at PyData London, and also Kafka Summit London, and Strata London. Apparently I'm going to London. Okay. So that's pretty much it. I have a flight in 1 hour and 30 minutes. Wait, 1 hour and 25 minutes. I can do like a question or two, and then I'm going to hop in a the thing, car.
Were there any questions?
Sure.
So we did a join of 4 million to 1 million on a pretty good POC that is 320 CP.
Wait, didn't you raise your hand for not using
Yes,
Spark?
That's why I'm doing the same point. So with the Hive on this, we got a pretty good result than Spark SQL.
Yes.
That's why I was like not much interested. I mean,
Yeah.
I don't know what we did wrong and we had to just scrape
Totally.
Spark from our product.
So, I mean, right. So Hivont has different defaults. And the Spark SQL defaults, as I sort of skimmed over, I dropped the pen, are kind of crap. 200 partitions is probably not enough for what you're doing. And so most likely, do what you need to do, if you wanted to use Spark in your workload, there's a tuning guide written by my former coworker, Anya Bira. There's other things. And essentially, it'll just lead you down a flowchart of which magical knobs you need to tune based on what your data set looks like. I have this like kind of out there plan of making something that'll automatically turn those knobs, but I'm sure it'll get it wrong for the first year. So yeah, I mean, most likely it's tuning without seeing your data. It's hard to say. Yeah, no, that sounds about right. No, like, I mean, if you were doing a join like that and you only had 200 partitions, like, that's just going to fail, right? You just have to up the number. And yeah, I mean, if you buy this high-performance Spark book on Amazon, you too can find some magic knobs to turn. But you can also go look at my coworkers, like GitHub.
I was a bit confused. So you wouldn't recommend using data frames even with the newer ML library?
So you can use, so I think the new ML library, I probably should have clarified this, so thank you for asking that question. You can totally use data frames with it. It's just if you want to write your own ML algorithm under the hood, you will not want to use data frames inside of your algorithm. So you're going to want to, you'll take in a data frame, but then you'll take this escape hatch into RDD land when you get to the iterative portion of your code. And this will allow the optimizer to do all kinds of things with, like, if you're only reading specific pieces of data, like narrow down the data which is actually going to get fed to the RDD. But, you know, when it comes time to do your iterative algorithm, you really need to do it in RDDs for now. Honestly, I don't know when that's going to get fixed. The SQL optimizer is like this giant collection of high-quality code that I don't want to understand. Like it's really good, but it's just like, ooh, I did not do a PhD in databases. I will leave this to people who did.
Other questions? So maybe the segue is we are giving away a signed copy of Holden's book today, but the first person to answer this question will get this book. And the question is, what is the name of the stuffed animal? Anybody know? If nobody knows, you can look it up, especially if you follow Holden on Twitter, and you can find me. I will be holding on to this book. The first person to tell me, you will be the proud new owner of a untarnished, free from cat fresh copy.
I probably should stop making that joke, shouldn't I? Yeah.
So with that, let's thank Holden again for refreshing the ocean and